California, renowned for seismic activity, has long anticipated a major earthquake. A recent study led by researcher Riley Hill proposes that a nearby body of water may impact the San Andreas Fault, potentially explaining the prolonged absence of a major earthquake. Some researchers speculate about the potential impact of dried-up lakes on seismic events, adding a nuanced dimension to our understanding of earthquake dynamics in the region. What is happening beneath the dried-up lake? In this video, we are going to find out the relation between earthquakes and tectonic activity to comprehend the potential connection between dried-up lakes and earthquakes. Without further delay, let's get started. Understanding earthquakes and tectonic activity. A solid grasp of seismic activity's fundamental principles is essential. Earthquakes result from the movement of tectonic plates, which form the Earth's surface. These plates undergo constant shifts and interactions along fault lines, fractures in the Earth's crust. The gradual accumulation of stress along these faults eventually surpasses their strength, culminating in a sudden release of energy, manifest as an earthquake. The well-known San Andreas Fault in California exemplifies a major fault system, marking the boundary between the Pacific and North American tectonic plates and a hotspot for seismic activity. Comprehending the behavior of these and fault systems is imperative for assessing hypotheses linking dried-up lakes to major earthquakes. The primary tectonic feature fueling seismic activity in California is the San Andreas Fault, a significant transform boundary. Extending approximately 800 miles or 1,300 kilometers through the state, it demarcates the Pacific Plate from the Northern American Plate. This fault accommodates the horizontal motion between the two plates, resulting in an earthquake. When stress is released, the San Andreas Fault is not a single continuous fault line, but rather a complex system of interconnected faults. It consists of several segments, each capable of producing significant earthquakes. The most well-known segments are the southern portion, which runs through the highly populated regions of Southern California, and the northern portion, which extends to the San Francisco Bay Area towards the northwest, apart from the San Andreas Fault. Reason of earthquakes pattern. As California harbors significant fault lines, such as the Hayward, San Jacinto, and Calaveras faults, the intensity of the overall seismic risk is undeniably high. Tectonic dynamics in the state result from the Pacific Plate's northwestward movement in relation to the North American Plate. The Pacific Plate advances at roughly 2 inches or 5 centimeters annually, prompting stress accumulation along the faults. The stress finds release through earthquakes when frictional resistance on the faults is surmounted. The presence of multiple major faults underscores California's susceptibility to seismic events, warranting comprehensive understanding and preparedness for potential earthquake hazards. It's vital to recognize the spectrum of earthquakes in California, ranging from minor tremors to major, impactful events. Throughout its history, the state has witnessed significant earthquakes, like the 1906 San Francisco earthquake and the 1994 Northridge earthquake. Given California's seismic vulnerabilities, extensive measures are in place to monitor and mitigate earthquake risks. The United States Geological Survey operates a network of seismometers and monitoring stations across the state, enabling the detection and recording of seismic activity. This data plays a crucial role in studying earthquake patterns, understanding fault behavior, and enhancing earthquake forecasting capabilities. Seismic activity. Now let's move on to the dried lakes, also known as playa lakes or ephemeral lakes, which undergo water level fluctuations due to variations in precipitation, evaporation, or human interventions like water extraction. Their potential impact on seismic activity is associated with several proposed mechanisms. One hypothesis posits that water functions as a lubricant along faults, diminishing friction and easing the sliding of tectonic plates. As water levels in dried-up lakes decrease, the reduced lubrication may escalate stress accumulation along fault lines. It's essential to explore these dynamics comprehensively to enhance our understanding of the intricate interplay between water fluctuations and seismic events. Accumulated stress may eventually reach a threshold, triggering an earthquake. Another hypothesis involves changes in pore pressure within the Earth's crust. When a lake dries up, the reduction in water pressure can cause alterations in stress distribution along faults. These changes in pore press might impact the stability of faults, potentially modifying the conditions necessary for an earthquake. However, it's crucial to note that the influence of dried-up lakes on seismic activity is considered a secondary or indirect factor compared to primary drivers, such as tectonic forces and fault interactions. Comprehensive research is ongoing to unravel the intricacies of these relationships. Primary cause. It is being assumed that the accumulation and release of stress along major fault systems, such as the San Andreas Fault, are the primary causes of earthquakes in California. While dried-up lakes may contribute to stress distribution on faults, it's crucial to understand the broader context of tectonic forces and geological processes. Earthquakes result from the release of accumulated stress over time, and the interaction of tectonic plates along fault lines plays a fundamental role. It's also important to recognize that California's seismic activity and the potential for major earthquakes are primarily driven by the complex tectonic interactions along the plate boundaries, rather than isolated factors, such as dried-up lakes. The Pacific and Northern American plates continually interact along the San Andreas Fault and other major fault systems, leading to the accumulation and release of stress that can result in earthquakes. Understanding the relationship between dried-up lakes and seismic activity in California requires comprehensive consideration of these dynamic geological processes. Scientific research. Comprehensive scientific research is imperative in understanding seismic phenomena. Scientists and seismologists employ diverse methodologies, encompassing field studies, laboratory experiments, and computer modeling to explore potential links and evaluate their significance. While the impact of dried-up lakes on seismic activity in California is a subject of scientific intrigue, it remains incompletely understood. Dried-up lakes may have secondary effects on stress distribution along fault lines, but they are not deemed primary triggers for major earthquakes. To fully grasp the intricacies of seismic activity in California, it is essential to consider a multitude of factors, including tectonic forces, fault interactions, and geological processes, while perpetuating scientific research in the field. The role of Lake Cahuilla. The researchers posit that the cyclic filling and draining of Lake Cahuilla, situated in the present-day Coachella and Imperial Valleys, played a pivotal role in stabilizing the southern San Andreas Fault. Their findings indicate a correlation between major earthquakes along the fault line and the lake being either full or in the process of filling with water from the Colorado River. This observation suggests that the substantial weight of the lake's water may have exerted pressure on the fault, potentially releasing accumulated stress and acting as a mechanism to impede seismic activity. The cyclic nature of the lake's water levels appear to have influenced the fault's behavior, revealing an intriguing interplay between water dynamics and seismic events in the region. Implications of Lake Cahuilla's disappearance over the past 3 centuries. As Lake Cahuilla gradually dried out, only salt and remnants of the sea were left behind. The study's authors posit that the slow depletion of the ancient lake played a role in tension accumulation along the fault, akin to stretching a taut rubber band. Consequently, the potential energy stored in the fault has increased, prompting concerns about the prospect of a notable earthquake in the future. The southern San Andreas Fault, part of a network of faults spanning California, poses a significant seismic hazard due to its proximity to densely populated areas. Understanding the dynamics of ancient lake interactions with fault systems is essential for assessing seismic risk in the region. With around 10 million residents in Los Angeles County alone, the potential consequences of a major earthquake on this fault are worrisome. The 1994 Northridge earthquake, though not directly linked to the main San Andreas Fault, led to over 70 fatalities and $20 billion in damages. Seismologists caution that the longer the period after a major earthquake, the more tension accumulates, increasing the likelihood of a significant seismic event. As a densely populated area with substantial economic impact, the threat of a major earthquake on the southern San Andreas Fault underscores the importance of ongoing monitoring and preparedness measures. Lake Cahuilla and rehabilitation efforts. Now, the recent research findings have raised important questions about the ongoing efforts to rehabilitate parts of the salt and sea originally formed in the early 1900s. When an irrigation canal burst, the salt and sea has become highly polluted and is shrinking to address these issues. Various plans have been proposed, including importing desalinated seawater and diverting Colorado River allocations. However, the study's authors caution that significant changes in the water level of the salt and sea could potentially trigger seismic activity. Therefore, a careful balance must be struck between environmental rehabilitation and the associated risks of exacerbating seismic hazards. The hypothesis, suggesting a link between dried-up lakes and California's overdue major earthquake, raises intriguing questions about the complexity of seismic activity. While the influence of dried-up lakes on fault behavior remains an area of ongoing research, it's crucial to approach the topic with caution and rely on scientifically supported evidence. Understanding earthquakes requires a comprehensive analysis of tectonic plate interactions, fault systems, stress accumulation, and geological processes. While dried-up lakes may contribute to the stress distribution on faults, it's important to consider them as secondary factors in the count of broader geological forces. What do you think of this phenomenon? Let us know. That's all for today. Make sure to like, subscribe, and press the bell icon for all future updates. See you next time.